Today we'll be completing Lesson 14, Infrared Receiver Module. For this lesson we'll be needing the Elegomega Mega 2560R3, an infrared receiver module, an infrared remote, and 3 F to M wires. Let's get started. The lesson starts with the objective, which is to connect the infrared receiver to the Mega 2560 and use a library that was designed for the particular sensor. I find this lesson plan very interesting because it opens a wide range of tantalizing use cases infrared has to offer for future projects and ideas that I have. Anyway, the lesson plan continues by introducing the IR receiver sensor. They decide to give a little crash course on infrared in general. More or less, they explain that infrared detectors have little photocells that look for infrared beams at specific frequencies, and depending on the frequency it receives, it carries out a command. For example, an infrared receiver might be programmed to turn on a TV when receiving a 35 kHz signal, and reduce the volume when receiving a 36 kHz signal. Okay, let's get into the wiring diagram, which is fairly simple. Very surprising for the most part. The ground pin connector connects to the G on the IR receiver. The 5-volt connector connects to the R on the IR receiver. And the D11 PWM is connected to the Y on the IR receiver. Alright, let's get into the code. We begin by including the IR remote.h library. So to do that, we click Sketch, include library, add .zip library. We're then going to want to locate our master folder, Elegomega, complete starter kit, English, code. We're going to go to lesson 14, and then we're going to select this library right here and click open. Next, we'll take a look at the INT receiver equals 11. This will assign the signal receiver to be controlled by the DPWM11 pin. IR receive and decode underscore results look like they originate from the library we imported. From what it looks like, the IR receive line will create an instance where the receiver can receive a command, and the decode underscore results will interpret it. We also have another line, void translate IR, which looks like it'll take the decoded results and perform an action based on the received command from the remote. All of these serial.println lines represent all of the different possible buttons that can send information to the Arduino. The case, followed by this weird string of alphanumeric characters that start with 0 and X, look like different frequencies the remote sends to the receiver. Then they set up delay 500 milliseconds so you don't get an immediate repeat from the buttons being pushed. Void setup starts by beginning serial monitor at 9600 bauds or 9600 bits a second. It also prints IR receiver button decode on serial monitor. And the last line will enable IR receive, which will begin the process of allowing infrared inputs from the remote. Void loop starts by stating that if the instance occurs in which a signal is sent to the infrared receiver, we will translate it using the translate IR command, I guess, and resume the process after the fact. Alright, with that out of the way, let's build it.